In this video, we are going to look at how you would write the Nuclide notation for an atom or an ion. So here we have the base format that our Nuclide notation takes, where X is our element symbol, and you would get this directly from the periodic table. A, so A is subscript, and that is our atomic number for our element. B is a little superscript b, and it stands for the mass number of an element. And C is our charge. And C is only present if we have an ion. So if we were just looking at an atom's Nuclide notation, we wouldn't see C, we would just have these three. Now, to be able to correctly draw a Nuclide notation, you need to know what the atomic number and mass number are of an element. And they are different for an atom and an ion. So you cast your mind back, we know that the atomic number of an atom equals the number of protons in the atom. And since atoms are electrically neutral, it also equals the number of electrons. We also know that in an atom, the mass number equals the number of protons plus the number of neutrons. And this is universally true. So this is true for the mass number of an ion as well. Now, when it comes to atomic number of an ion, atomic number does of course equals the number of protons. However, with an ion, it is not equal anymore to the number of electrons. To work out the number of electrons in an ion, we need to look at the charge. Let's work through some examples for writing Nuclide notation. So here for example 1, we can see calculate the number of protons, neutrons and electrons in each of the following elements. So here you're given the Nuclide notation and you're asked to work back the way and to write out the number of the subatomic particles. The way I always do this is I think pen, and I write that down outside, and then I start to work through. Now the number of protons is equal to the atomic number, so that is 11. Here we do not have any charge, which means that we have got an atom. In an atom, the electrons is equal to the protons, which means we have 11 here. And our neutrons is, remember, the mass number equals the number of neutrons plus the protons. So to work out neutrons, we do the mass number minus protons, 23 minus 11. If you get confused by working out the number of neutrons, here's a handy hint. The sum is already laid out for you. 23, put your minus sign in, 23 minus 11 gives you 12. Let's move on and work through B. So here we're going to do the exact same thing. Our atomic number is 8. We have an atom, so we have 8 electrons, and our number of neutrons is 16 minus 8. So that is going to be 8. And for our hydrogen atom over here, you can see we have an atomic number of 1. So our electrons are going to equal 1, and our neutrons is 3 minus 1, which gives us 2. If you want, you can pause the video here and work through the next 3 on your own before coming back and marking them. Okay, now we are going to look at how you work out the number of protons, electrons and neutrons when you have the Nuclide notation of an ion. So here we can see that we have a 3 positive charge on this aluminium ion. So we'll start out as we always do, write pen. The protons is equal to the atomic number, to put that in as 13. This time our electron count is going to change because here we've got 3 more positive charges, so what that means is that we have actually lost 3 electrons. So we can put in our original electron count of 13. Now if you change the sign on a number, remember if you change the sign, you change the sign. So essentially what this is going to happen is this 3 positive charge is going to hop over the top of the aluminium and it's going to become a -3, and that's going to tell us that we actually have 10 electrons in this aluminium ion. And again, our neutrons are worked out by doing our little sum. 27 minus 13 gives you 14. And let's consolidate that by doing another positive ion example. So our protons comes directly from our atomic number. Our electrons, we can write out the number of electrons we would have had in an atom. And then we have a look, we've got a 2 positive ion. Remember, as it jumps over the electron symbol, it's going to change sign. Okay, so it's 30 minus 2, so here we have 28 electrons. And again, for our neutrons, you just work out the sum. 66 minus 30 gives you 36. Now here we have a negative ion. So this time we have gained extra electrons. So we'll start with protons. We can see it's 16. When we look at the electrons, we can think, okay, we started with 16 electrons in a neutral atom. This time we have gained 2 electrons because we've got a 2 negative charge. So again, when this charge jumps over the element symbol, we change the sign. So it's 16 plus 2 this time. So now we have 18 electrons. And for our number of neutrons, it is 32 minus 16, which is 16. And that's how you would work out the number of protons, electrons and neutrons in an ion. Let's look at a different type of example here. So here we're given the sentence, write the Nuclide notation for each of the following atoms. An oxygen atom with 10 neutrons. Okay, so let's look at how we would start this. So the first thing that we would do at this point is we know it's an oxygen atom, so we can put our element symbol in. Because we know the element symbol, we know that the atomic number of oxygen is 8, so we can get that straight from our data booklet. It's telling us we have 10 neutrons. Remember, our mass number is equal to protons plus neutrons. So we have 8 protons from our atomic number and 10 neutrons. Therefore, we have a mass number of 18, and we can just put that in. And it is an atom, so we don't need to worry about any charges. Okay, and let's work through the second one of these. We have an atom that has atomic number 6 with 7 neutrons. So if we know the atomic number is 6, we can look up our data booklet and find out that the element in question is carbon. And we can put our atomic number in. We're saying it has 7 neutrons. Again, to work out mass number, it is protons plus neutrons. So it's 6 plus 7, which is 13. Oh. So we can put that back in. And again, just to check, it is an atom, so we don't need any charge, so you shouldn't have anything over here. Now let's practice this style of question when writing ions. So here it says we have an ion with 17 protons, 20 neutrons and 18 electrons. So the first thing I'm going to do is I'm going to write it out like this, because it just makes it much easier for me to visualise it this way. So I can see my protons, electrons and neutrons. Since my protons is the atomic number, I can look in my data booklet and find out that the element with atomic number 17 is in fact chlorine. So I can go ahead and put my atomic number in. I know that my mass number equals the number of protons plus neutrons. So I can do 17 plus 20, which will give me my mass number of 37. We can pop that in the correct place. And then what I have to do is just look at the difference between your protons and electrons. Here we have gained 1 electron. So remember, that means that we have 1 extra negative charge. So I can put that in as my little negative symbol. You could put a 1 here, but usually when we only have one negative or 1 positive charge, we don't bother putting the number in. However, it wouldn't be considered incorrect at National 5 level. And here we have an ion of cesium with mass number 133. So again, if we know that it's cesium, we can look up the symbol in the data booklet. From that we can find out that our atomic number, i.e. our number of protons, is 55. It tells us our mass number is 133, so we can fit that in. Now we know that cesium is in group 1, it's an alkali metal in the periodic table, therefore when it forms an ion, it will lose 1 electron, giving it a 1 positive charge. And that's how you would write that example.